In this lesson, I'm going to show you how to design and build a table inside your SQL database. In fact, we'll do multiple tables inside this demo. Now, the table is the heart of a database because that's where the data actually lives. All the rest of the stuff kind of revolves around displaying the data or combining the data or updating the data or securing the data, but all it focuses around that data, and the data lives inside tables. So this is really the important part, the most important part of your database. Now I've got SQL Server Management Studio, or SSMS, open over here. So let's open up our database called timesheets. Remember, we're building a database that holds all those timesheets for a consultant or someone like that. So in here we have tables, and right now we have no tables. So let's right-click on tables and say New Table. This is the easiest way that I have found to build a new table because it's actually a dialogue-driven or menu-driven, option-driven system instead of just having that blank query window and staring at it saying, now what do I do again? So this really helps. Now, before we get too much further into this, I want to stop for a minute and just talk you through really where I am in the process and where you should be in the process. When you're building a database, you should not create the database first and just start throwing tables in there until after you have designed it, after you sat down and said, this is the data I want to store, and here's how I want to store it. Now, I've done that behind the scenes just because it's not really easy to show you how to do that. It really is just a matter of experience over time building tables to know, oh, I should do this, I shouldn't do that. So I'm going to show you by actually building the tables, and while you could do that too, I would say instead start with a piece of paper and a pencil, or maybe an Excel file so you can have the name of the table up top, and then you have every cell below it is the different fields you have, or maybe you want to do it in OneNote because that's kind of easy to put different pieces together. However you want to do it, I would design it first on paper because it's a whole lot faster to erase a column, move a column to a different table, and those type of things if you're on paper versus this actual designer. So, but once you've got that design in place, and I have that design in place, but once you get that design in place, then you come here to actually build the table. So what's the first thing you should start with any table? Here's my advice. It's not something that everyone does, but I would encourage you to create an ID field first. And in fact, I call it ID. And I give it a type int. Now an int is a number, and that number is a whole number. So it's 1, 2, 3, 4, 5, 6, 18, 25, those type of numbers. It can't be 1.2, it can't be anything other than a whole number. So I call it ID just because in my practice, what I do is say that the primary key column, which that's what this is going to be, is a primary key. The primary key column in a table, or the row or the column that identifies every record uniquely, that should just be called ID. So that's my thing. You could call the table name ID. So this is going to be the employee table. So you could call it employee ID, but I just call it ID. So we have the column name, and that can be any type of character or underscore. So a letter, just stick with letters and underscores, and really just letters is what I'd encourage you. Don't put spaces in. Don't do other things. Try to avoid the reserved keywords. So I avoid common words like name, just name, not first name, but name. Where, select, table, those type of things. If you have to use something like, say, table, I wouldn't just call it table. I would call it table name or table type or whatever an added descriptive word to that would be, so that it's not just that one word. So in this case, we have ID. The data type, there's lots of different data types, and we'll talk about quite a few of these as we go. And I find it's best to learn as you need them, rather than learning everything and trying to remember everything. So let's learn as we need them. So this is the int type, which is a whole number. And then this allow nulls. So what this does, if this box is checked, and it says allow nulls, which is the default, then when a person is filling out a row in our table, they don't have to put a value in this column. And if they don't, it will be a null value. And we'll actually say null when we see it. That's different from being an empty value. That's different from being a 0. A null is something different entirely. Now for our identifier column, the ID column, we can't have nulls. So we're going to uncheck that box. The next thing I do is I set this column as the primary key. And up here in the right, you'll see this key icon. And it says set primary key. Go ahead and click that, and I'll zoom back out so you can see what happens. Notice over here, we got a little yellow key next to our ID. And what that indicates is that this column is now the primary key. And you may ask, well, what is the primary key? That's a great question. The primary key is the way that SQL Server is going to identify each individual row, which means the primary key cannot have the same value in two different rows. So let that sink in for a minute. The primary key has to be unique. All right. Now with an ID column, and it's a number, what the common practice is to come down here. Notice the property windows for the column property windows. There's an identity specification down here. If we expand that and say yes to is identity. Let me zoom in there. There we go. So is identity is yes, and the identity increment is 1, and the identity seed is 1. So what does that mean? Well, when we said that yes, this is an identity field, it set up a counter basically. And that counter starts at the identity seed, which currently is 1. So the first number it's going to start at is 1. The identity increment is the amount that counts up each time. And that also is 1, which means the next number will be 2, and then 3, and then 4. If that identity increment was 3, the next it'd be 1, and then 4, and then 7, and then 10, which would be kind of awkward. But the standard is what we keep here usually, and that is start at 1 and count up. So row number 1 has an identity of 1. Row number 2 has an identity of 2, and so on and so forth. Now the great thing is, because I set that up, SQL Server will take care of this for me. I don't have to then touch the ID field ever again as far as trying to update it. I can let SQL Server manage that for me, and it will do so in a way that is unique. It will never put the same value in a row as another value. So that's the identity field. And we'll see this in action a little bit. It'll probably make a little bit more sense when we start looking at why we have this identity field. But for now, we want to make sure that we have this identity. Now remember I said that the identity field is used to order this table by SQL. So what happens behind the scenes is that we have a whole bunch of rows. Say we've filled this table up, we have 100 rows. SQL has to know how to order those in storage. Now, if we did not have a primary key of any kind, we'd have what's called a heap. And what a heap is just what it sounds like. Think of it as a garbage pile. Every time you get a new row, it just tosses it on top. And it's kind of a mess. There's no real order. There's no real rhyme or reason as to why they are in the order they are. They're just thrown there. That's not efficient for getting information out of. Think about rummaging through your pile to find that one piece of information you need. It's going to take a while. The same thing is true for SQL Server. So what SQL really likes is to have some type of key that it can say, okay, this is the primary key. This is what I'm going to order by. Now, because I have this auto-incrementing column, it makes it really simple because it says, okay, the first item is number 1, so I put that in my storage. The next item will be number 2, therefore I put it after the first one, which putting things after the last entry is really easy to do in memory. So essentially, we're making this easy for SQL to add new records to our table. Which we want that because the easier it is, the faster those records go into our database. Now, some people will say, I don't want a primary key like that. I want what's called a natural key. And the idea behind a natural key is think about, say, a person table. Say if you took a person's first name and their last name and their phone number. If you had all 3 pieces of information in the table, that would probably be unique, right? I mean, who has the same name as me and also the same phone number? Nobody. Therefore, we could say those 3 columns combined make the key. And so what will happen is SQL Server will then order that table based upon first name, last name, and phone number combined. Now think that through for a minute. When you insert a new record, where does it put it? Not at the end. It puts it wherever it fits in that order, which means maybe halfway through, maybe near the beginning, maybe near the end, maybe at the very end, who knows? And so it takes a little longer for SQL Server to insert that data. And it sometimes has to rearrange whole sections of data based upon how the memory lays out. So that's not real great. I don't really like that idea. Some people really love the idea of natural keys. I personally like to see the primary key be just an identifier that's an auto-incrementing number because it makes life easier for SQL Server. It makes life easier for us when we're talking about trying to link 2 tables together because it's hard to link against first name, last name, and phone number, where it's really easy to link against this ID. And if you say, well, I could create an auto ID as well, then why don't you just make that your primary key? And that's where I come to it. So that's my opinion. That's the opinion of a lot of SQL developers, but not everyone. So I just want to let you know there is a little bit of debate there, but this is the way I'm going to push you to go. Okay, so back off the rabbit trail and back onto our columns. So this is the employee table, and I'm going to store basic information about an employee. Now, we could go way down the rabbit hole with this database, but I'm going to try and limit it to just a few tables, say 5, and then a few queries and a couple of store procedures, just enough to get you to understand how a database works together. So when you look at this, there may be ways to make this a little more optimized for a large environment. But you have to know your environment when you're building an application or a database. Because if you got a small consulting shop, for example, the consulting company I worked for, we had between 4 and 8 employees at any one time. So that's not very big. So we didn't need a huge database with millions of records and millions of people and stuff going in and out at a crazy rate. We had a very limited set, and therefore a simpler database would actually work better. So whenever you see a tutorial or something online that says this is the way to do something, take that with a grain of salt, because typically it's the way to do something within a certain set of circumstances. So in this set of circumstances, my goal is not to have every single table I need necessarily, or could want to have, but instead have the ones that make the most sense. So I'm going to store first name, and notice no space, but I did capitalize the first letter of each word. Now, first name is a text field. So what type of data type do we need? Well, there are a number of options. The suggestion right now is nchar. There's also some other types. For example, there's ntext, there's nvarchar, there's nvarchar max, and down here there's text, and then there is varchar and varchar max. I'm sorry, that's var binary. Varchar and varchar max down here. So all those could be text types. So let's talk about the differences between these. So char, let's start with char. A char field says that it's characters, anything you want, numbers, letters, special characters, spaces, whatever. But what this number afterwards says, this is how long that field is going to be. In this case, it's 10 characters long. Now, that wouldn't be enough for a first name, but let's say it's 100. So we're saying nchar 100. I'm sorry, char. I selected nchar for some reason. There we go. Char 100. So with a char 100 field, if my first name is Tim, and it is, that's 3 letters, T-I-M. So I have 97 left over. So what the system does is it puts 97 spaces in there, because every first name is going to be exactly 100 characters long. And if it's not 100 characters long, we're going to add spaces to the right to make it 100 characters long. And there are purposes and reasons behind that, but typically I don't find this is a very useful field for the majority of my databases. So that's char. Now is also, let's skip down here to this, varchar. What's varchar? Well, varchar is a character field in that it allows us to store, again, letters, numbers, special characters, and spaces. But even though I said 100 here, what I'm saying is up to 100. This var stands for variable. It's a variable length char field, which means that if my first name is Tim, it stores 3 characters. That's it. So with just 3 characters stored, the row, the field actually, in that row takes up a whole lot less space. It's also a whole lot cleaner to work with because you don't have to trim off those spaces to the right. So variable length char field is very nice. And so varchar is a pretty common character field or text field. Now we could use nchar. Now again, what does nchar do? Well, it is the char, which means it's going to be 10 characters or 100 characters, whatever you set. It's going to be that long, but the n specifies that it's Unicode characters. Now, Unicode characters take up a larger set of characters than our standard keyboard, at least our standard English keyboard. And I am from the US, so we deal usually with the standard English keyboard. But we have a larger set with Unicode where we can have things like Chinese characters or other special characters that are different than what I would consider the usual characters. So that allows us to store Unicode either in a char or also in a varchar. So down here is nvarchar. So again, it's Unicode, it's a variable length, and it's a character field. So that's nvarchar. Now, the other thing I have to deal with is this nvarchar max and the varchar max. And what do those mean? Well, the max is, instead of giving us a number, the number of characters, we're saying it's a very, very, very large amount of characters, possibly. And so that reserves special space actually outside of this row's data. It actually stores it in disk in a little different way. That's really behind the scenes deep dive stuff. But what it does is it allows us to store a really large amount of data in text in this field. And so since we have nvarchar, what that allows us to do is store Unicode characters in a variable length to the maximum allowable for text. And if you want to look that up, it's pages and pages and pages and pages of characters. So we're talking book size space. So I don't think you should have a problem ever with nvarchar max or varchar max. So which do we do here? Is it varchar or nvarchar? Do we need the Unicode or not? Because Unicode takes up twice as much space per character as non-Unicode characters do. So if we go the Unicode route, we're making our text fields twice as large as they need to be if we're not using Unicode characters. Now, if we are, we're making them exactly the right size. So that's really up to you, but it is a decision you should think through. It's not just a flippant, oh, just use nvarchar, we're covered. Now, in a small database, that probably doesn't matter. And so you could just use nvarchar. And you could even use nvarchar max if you really wanted to. I would recommend against it. It's not as efficient. Or nvarchar max, I mean. And so ignore text, ignore ntext, and while you're at it, ignore image. Those all go. All right? Okay. Now, the next column is allow nulls again. Do we want to allow null values for first name? Is there ever a case where we want to allow someone not to provide their first name? My answer, no. Therefore, I uncheck it. There's some other stuff down here I want to point out. We'll use it in the short term, but I want to point out there's a whole lot of other properties down here, but the key ones I want to point out are the default value or binding. If we want to, we can set up a default value. So even though we said don't allow nulls, what we could do is say, if there is no value given, use this as the default value. So we can put Bob in there. And then every time we create a new person, if they don't give us a first name, their first name is now Bob. All right. And so that could be valuable. It's really not for first name unless you want to call everybody Bob. But there are any times when you're going to use that. So next, last name. Again, varchar. Do we want to make it bigger than 100 characters? Maybe. Okay, you have to look at it really helps to have a list of names, but look at your names that you're going to have to use. Are there any that are crazy long? This has been exacerbated by people with hyphenated last names. Now, usually people who have really long last names may not want to hyphenate them, but pretend they did. A person who has a 53-character last name gets married to a person who has a 45-character last name. Seems ridiculous, probably, if you think about it. But if that were the case, that hyphenated last name would be almost 100 characters. Now, the reality is probably we can get away with 30. But 100 seems safe to me. And since it's a variable length, it's real okay that that's 100 and kind of overkill, because I'm not actually using that space if I don't need it. All right. Again, we're not allowing nulls. Next, email address. Length. Well, let's do varchar. This one's a tricky one because I believe the actual maximum length of an email address is 2,000 characters. It's something ridiculous like that. Here's the reality. Even though that's the max possible, and some joker probably has an email address that long, who is going to type that in? I would love to see the business card for the person who had an email address of 2,000 characters long. It'd have to be a 8.5 by 11 business card or something, or it'd scroll in really tiny font, go on the back or something like that. Maybe it says part 1, part 2, and part 3 on the business cards. Anyways, I digress. So an email address in reality is going to be no longer than 100 characters. Again, people have to type this in. They're not typing in a 150 character email address all the time. Now, should we allow an employee, remember this is the employees table, should we allow an employee not to give us their email address? Well, no. Because we're providing them with an email address usually. When I sign up for a company, usually the first thing that happens is I get an email address. Therefore, that's not going to be allowed as null. Now, we could go into a lot more fields that an employee should have, and if this were a full-fledged HR system, yeah, we'd need those things. But the reality is, all I need access to is their name and their email address. So we're going to leave it at that. But we are going to add a couple more fields. One is going to be pay rate. And this is the amount of money they get per hour. Now, what we're thinking here is that our employees are going to build out at a certain rate, at the bill rate, but then we also pay them per hour at a different rate, hopefully less than what we bill the customer for. And that's our profit margin is the difference, or at least part of it is. So the pay rate is what this employee gets per hour. So what type is that? Well, if you are a C# developer, you'll know that we have a difference between double and decimal. Double is a number that has a decimal point, which is kind of confusing. So 1.23, that can be a double, or it could be a decimal. The difference is double is not entirely precise. We're talking after the 18th place after the decimal, that's when it starts to get a little squirrely, okay? Which, who really cares for most things, but when it comes to money, we really care, okay? And that's where decimal comes in. It's much more memory intensive, but it's super precise. In SQL Server, we have this thing called float. We have decimal, and we also have money. Guess which one we store money in? That would be money. Okay? It's precise, it's great, it works. So therefore, money is our type. And then allow nulls. No, we don't want to allow nulls there. And in case you're wondering, the difference between the decimal and the money is all a matter of the place at which it holds. So decimal place, we can specify, only 2 places after the decimal or 15 places after the decimal. Whereas money, I believe, is 5 places after the decimal is what it holds. But there are instances where systems like the analytics server will not accept anything but money for that type of type. It doesn't accept the decimal yet. So that's a possibility you run into. In general, if you're storing money in a SQL server, you use money. And then float is kind of like the double in C#. It's the a little bit rounded, but again, way down the pipeline. So there is some imprecision there. So again, money. All right, so pay rate, we're going to leave that unchecked. We could, if you wanted to, say typically all of our employees start at or are at $20 an hour. We could come down here to our default value or binding and put 20. And that puts it in parentheses when I move off it. And then anytime an employee gets created, if we don't specify their pay rate, their hourly wage is $20 an hour. That's what's assumed. So we could do that if you wanted to. We're going to leave that off. Now we have the bill rate. Same thing, money, not null. In this case, we will set a bill rate. Let's set a bill rate of, let's make it really easy and do $150 per hour, $150. So that way we know exactly what we're expecting unless we change a bill rate for a certain customer. Because that makes sense, right? You have your normal hourly rate, and then certain customers might get a discount, and so we change that bill rate for that customer, for this employee. For example, if I were, really good at project management, and so I was a little more customized in that area, I might get one billing rate. Whereas if I'm a developer, a software developer or a database developer, I might get a different pay rate or bill rate we bill the customer. So I had that happen to me a lot when I was hiring consultants. I would come to a company and they'd say, okay, we're going to give you 2 developers at this rate. We'll give you 1 project manager at this rate and a database person at this rate. And they were all different, but they were all standard. So that's our pay rate and our bill rate. So now we can hit save in this because this table actually is almost done. We're not quite done yet. I almost always forget to add a couple of key fields here. So a pretty common standard is to have a created date or create date, and then also to have an update date. Now let's last updated. And I'll leave those, I'm going to talk first what I do, and then I'll set their data types. So create date and last updated. What the And then down here for create date, I'm going to say either get date or get UTC date. The difference here is whether I want to have the time be in what used to be Greenwich Mean Time, the 0 hour. It's the when you have time zone offsets, the time zone offset is 0. And so that way it's independent of where the server is that's running this SQL Server. Because if I just say get date, what it's going to do is get the date and time where on this local machine, the local machine that SQL Server is running on. If you have two servers that are replicating to each other, and one's on the East Coast and one's on the West Coast of the United States, the time difference is 3 hours. So when one says, I wrote a log entry at 5 p.m., the other one says, no, I wrote a log entry at 2 p.m. And so the one, or 2:01 p.m. And so 2:01 p.m. will order first in a list of ordered dates, but the reality is it happened second because it's really 5:01 p.m. on the East Coast versus the 2:01 p.m. And so it gets really confusing if you're going to deal with servers on different coasts or moving a database from one time zone to the other or having people come in from other areas. And so if you do have that potential, I would definitely encourage you to do get UTC date. But if you don't, it's a whole lot less confusing to have just get date. And that's, zoom in here. Just get date, open, close paren. And we'll do the same thing for last updated, even though we're actually going to update that whenever we update this table. But the first time we create the entry, we'll have both of these match. So that is the employee table. We save it, and it's going to ask us what name do you want to give it. And I want to call it employees. All right, and now if I come over here and I refresh, for now, we're just actually building our tables. Okay, we don't want to get bogged down too much, so let's go ahead and go to the next table. So right-click on table, say New Table. Again, we start with ID, make it an int. Don't allow nulls. Check the Set Primary Key. Scroll up here, say Identity Specification. I double-click to say yes, or you can do the drop-down over here. Once you say yes, it sets up the defaults just fine. And now that row is done. Now this is the customer table. These are our clients, the people that we work for. The companies like Acme Corp and XYZ Corp and ABC Inc. So we want to first have a company name. And that would be an nvarchar, or let's do a varchar and make it 100. Don't allow nulls because the company name has to be given in order for us to identify which company it is. Phone number. The data type for this is varchar. Now, the name number kind of throws you for a loop there probably, because phone number isn't really a number. It uses the number characters, but the reality is that it actually is a string. And the reason why is because, first of all, we have the open and closed parens around the area code, the +1 if you are using the country code, the dashes between sections, or the dots, or other things to separate those numbers. All those things are not really numbers. They're not numbers. And so to try and treat them like numbers is a problem. Now, you could say, well, I'm going to strip out all that information and have just a number. Well, okay, but is it a number? No, it's not a number per se. We can't add to it or subtract from it. We can't multiply it or divide it. It's a unique identifier that just happens to use numeric values. And so therefore we want to store it as a varchar. Now I put varchar 20 when I don't know of any number that's that long. Probably I could get away with more like 14. But just in case, 20 is fine. I'm not using up extra storage space, but I am being flexible in that. All right, now allow nulls. Nope, I don't allow nulls. Next is email. The primary person we're going to email at this company. So again, varchar, and we'll set it at 100. Again, not null. Now, that's all I have for the customer table. That's really all I need. So I still need that create date and last updated. Now check out this little trick. If I highlight by clicking over in the gray space and then hold down my shift key and click to the end or the last row I want, it highlights both of these rows. Now I can hit Control C, come over to table 1. In this empty field here where I don't have anything, but I have this empty row, if I click on the left, and it's a little hard to see, but it's a slightly grayer square here. If I click on that and I say Control V, it pastes those two fields in. Even better, if you look at the create date, notice the default value down here is get date. And the same is true with last updated. It's got its default value. So it brings in all that information and sets it up the exact same way. And why is that really cool? Well, first of all, it saves me typing. But second of all, I now know that these two fields, which should be common among all of my tables, are going to be common among all of my tables. So that's pretty cool. So let's save this. I call this customers. So now I have two tables, employees and customers. Now let's create a table, a really simple table. So right click, new table, ID, int, don't allow nulls, check the box for primary key. Is identity? Yes. So that's our ID field. And now you want to say job name. It's the job table. So varchar, let's give it 100 just because we want to make sure we have a descriptive name if we need it. Don't allow nulls. Now you could put job description here if we wanted to get into what the job's about and all the rest. I'm assuming that this is just about capturing timesheets and not about an entire system for tracking jobs and what the pay rate is and all the rest. I'm assuming this is just pretty straight up. This is the job and I worked on it or I didn't work on it, and here's who worked on it. So therefore, I'm not going to include a description here. But I do need a customer ID. And what is that? It's an int. It's not null. And what this customer ID is it links back to our customers table to this ID. And this is one of the real key tenets of a relational database. So I am saying here in this table that I need the ID for a specific customer. So the job name, that's pretty self-explanatory. Say, build software application for who? Well, for XYZ Corp. But I don't put XYZ Corp here because that would be duplicating all their information. Their name, their email address, their phone number, and all the rest. Instead, I put an ID, a number, that represents the specific row in the customers table that has XYZ Corp's information. So now, if I have 3 jobs for XYZ Corp and their ID is 5, I'll have 3 jobs in this table, each one of them having an customer ID of 5. I've duplicated a number, and that's it. This is what's called a one record here, to many relationship. One record in the customers table can link to 0 or more records in the jobs table. And that's a one-to-many relationship. And we'll actually draw that out in our diagram in a little bit, so you'll see that. So for now, let's move on. And that's really all we have for this table, except for those last 2 entries, which I still have in my clipboard, I believe. Nope, they're gone. Okay, so I will copy them again, and I'll paste them again. There we go. So now we have them back. So again, create date and last updated. I'm going to save this and call it the jobs table. Well, just jobs. Sorry. Okay. So now I have these 3. And it's one you may have been thinking about, or part of one that you may have been thinking about that is kind of missing. That's the customer table. It doesn't have an address. Where are they located? Well, think about that for a minute when it comes to companies. If you deal with only small companies, sure, one address. But think about a larger company. Maybe a company that has locations all over the world. Which location would you put for their address? And this is where especially rookie database developers get into trouble, is they start by saying, well, let's put the address right here. Address, city, state, zip is 4 different entries. Cool. And then they have the instance, they put it in production, and their boss comes to them and says, okay, but Acme Corp has 2 locations. And the DBA goes, oh no. So he goes back to the table and says, I know how to fix this. And he copies those 4 lines and pastes them again and calls it, street address 2, city 2, state 2, and zip 2. And all is good again. Until XYZ Corp comes along and they just bought up another company. They actually have 5 locations. And the boss looks at the DBA and says, well, do what you did last time. And they go, that's a problem. Now I've got an extra, 12 more columns. And pretty soon you have a ton of columns. That's not sustainable over the long term. I've worked with database tables that have had over 200 columns because of this type of thinking. The just one more. And it's not sustainable over the long term. So when I looked at the customers table, I said, nope, I'm going to have 1 email address and 1 phone number because I have 1 point of contact. That's my assumption based upon my knowledge of the business rules. If you didn't know to assume that, you'd have to ask your boss. He may say, nah, we got 3 or 4. Then you'd have to figure out, okay, how you create a phone number table, an email address table. But in our case, I said, nope, 1 per. But I said, we do have multiple locations. Therefore, I'm going to create a new table to hold those locations. So let's do that. ID, int, don't allow nulls. Check the key for add primary key. expand identity specification down here. Say yes for is identity. And now I can start on the actual entry. Street address. And that would be a varchar. And let's make that 100. Don't allow nulls. City varchar. Let's put it at 50. State varchar. And again, this is an assumption that it is a US-based business or close enough that its state is meaningful in some way. And so I'm saying, again, 2, because in the US we have every one of our states has a 2-letter acronym. So I live in Pennsylvania, therefore it's PA. So that would be your state. Allow nulls is no. And zip code. Is it a number? Nope. Varchar. And in fact, I'm going to put varchar 20 because I'm going to assume that we might at some point go into Canada. And Canada has letters in their zip code. And that wouldn't work in a numeric column. And so I definitely don't want to have my zip code to be just numeric. Also, the zip codes in the US, there's one area that actually has a zip code that starts with 0. Well, what happens in a numeric column when you start a number with 0? It drops that 0 off. Getting those. I'm just so eager to get the tables done. So, this is called locations. So the final table we have to do, let's refresh this so you see it. The final table we have, now let's create the ID for this. IDs become quicker and quicker as you do them. You get used to doing the same thing over and over again, which is good. You want to have that same repeatable feel to every single ID you do, because the killer here is when you forget to do something once. It'll mess with you. So make sure that you always do the same thing the same way every time, just to help you get in that groove, always doing it that way. All right, so this table is the work done table. This is where the actual timesheet idea sits or fits. Because we have employees, we have customers, we have jobs, we have locations. But the actual work that's getting done, where does that go? It goes in the work done table. And this table is a fun one because it's got a lot of IDs. So first of all, it's the employee ID. And that is the person who is doing the work. Next, it's the job ID. Again, int is the data type. And that is the job that we're working against. So build software application for XYZ Corp. Well, that's the job. Tim is the employee, so Tim is working on the job, build software application for XYZ Corp. The next thing is the location ID. because Tim may be working in the Saskatchewan office, or he may be working for the Memphis office. And they could be for the same project, or they could be for different projects. But usually, companies want to see a breakdown based upon location where you worked, because usually they bill that location for that work. So therefore, job ID and location ID give us all we need to know. Now you may be wondering, what about customer ID? Well, we don't need it because the location is tied to a customer. Therefore, we know exactly which customer it is because we know which location it is. All right. Next, we have the hours worked. What is this? Well, it could be an int, it could be a float. That's up to you. I'm going to put it as a int. I'm going to say, you know what? We round everything to the whole hour. Now, a lot of companies will say, no, we do to the half hour, build a quarter hour increments or something like that. Nope, we build to the whole hour. If I wanted to build to the partial hour, I would use float. All right, so that would be my choice if I wanted to have a decimal number in there, a number with a decimal place in it. So you float. Again, do not allow nulls. Now we could, if we say that, whenever we're called in to do work, it's a minimum 2 hours build, we could come down here to our default and say 2. Because then that way, every time we work, it defaults to that 2, and we only change it if we do more than 2 hours work. So that's up to you. I'll leave it in there as a default, just so you can see how that works. Description. This is a varchar, and this should be very large. We could do a max if you wanted to, but in this case, I'm going to do a varchar of, let's do 2,000. We're not going to allow nulls, and that is them saying, this is what I did. And so again, we should want a larger amount of text for that. Finally, the date performed. So this is when they actually did the work. Now, we could put a date time too here, but we didn't perform it on that particular hour and minute. We performed it on that date. Therefore, let's just use the date. So that's just the date field. There's also down here a time entry as well. And that allows us to do just time if you want to. But in this case, just date is fine. Now I could default it to today's date, but I'm not going to. And the reason why is because I want to say that, one of the things that I did, and I had a bad habit of this, is I would kind of scribble some notes down on a piece of paper somewhere and just keep working. And scribble some notes down, just keep working. And then at the end of the week, when accounting's coming to me and saying, so did you work this week? I go, oh yeah, timesheets. And I'd quick get my timesheets out and I'd start filling them in and look at my notes and fill them in, look at my notes and fill them in. And so I would fill in work for 4 days ago, 5 days ago that I did. And so that date performed, I don't want to default it to today because I might be changing that quite a bit. And then we also want to have our create date and last updated because those definitely could be different. Again, take me for example, I might be entering it on a Friday, that's the create date, for the past Monday. That's the date performed. And maybe my boss has a policy where you have to enter it within 3 days or, they dock your pay, or I don't know. But that would be a very quick way to tell if you entered it in time or not by having the create date and date performed checked against each other. So that is all we need for this table, the work done table. All right, congratulations. we have now created 5 tables in our database. That is all the tables we're going to need to work with our timesheets system. In our next video, we'll go into how to fill these up with data. There's a few different ways of doing that, and so we'll go over all those different types of ways just so you're comfortable with either the editor or the query window or some other ways. And so I'll show you all those in the next video, but for now, we've got all of our tables completed. I'd recommend, as I always do, that you practice this before you're moving on. So practice what we've learned, build some tables. It doesn't matter if they are the same tables or not. You could. That would definitely still give you the skills that you need, or at least practice those skills. But then I would also encourage you to branch out a little bit. Try something different. Here's an example. Think about your Christmas list. Maybe you send Christmas cards out to people. Create a database for those Christmas cards. So what do you need? Well, you probably need people and their addresses. Maybe that's in the same table because you're only ever sending to one address. But what happens when you update an address? Do you want to keep the old address? Is there a separate table for past addresses and who they link to? Is there a table for cards that you've sent? Maybe you want to keep track of, I sent them 5 cards. And you also want to keep track of how many cards you got back. So you can do a comparison and say, I am better than them because I sent them 5 cards and they only sent me 3 cards. Now that's pretty petty. But if you want to do something like that, you could do that. So that may be a good practice for you. Create a Christmas card sending list with a table that tracks which cards you sent out. So it'd be a cards list table as well. And then a cards sent table would track the card and the person. So track those 2 things in a separate table or combined in a separate table. And then you can keep track of how many cards you sent and to who you sent them to, and maybe even have a table that says cards received. And again, link those 2 up as well so you can kind of keep track of those things. All right? So like I said, you don't have to do that, but I would definitely recommend practice, practice, practice. It'll make all these next steps easier because you get more and more comfortable. It'll also allow you to bump against some other data types that maybe we didn't cover. I covered all of the major ones, but if we look through this list, there may be others in here that you say, wait a minute, geography, we didn't cover that. Well, that's latitude and longitude, and no, we're not going to cover that. But if you want to cover that, maybe you can go out there and Google and find out what the geography type is and learn more about it. And maybe that's really what you need, okay? But like I said, I covered the major ones, but there may be others in here that you go, yeah, I kind of want that. So you only find that through practice, and I definitely recommend that. All right, now I'll have some homework at the end of this just to kind of encourage you along that way as well. All right, so that's it for this lesson. Next lesson, we're going to put some data into tables. Can't wait.